Hi everyone and welcome to Opusmodus. In this video I will give you an overview of the UI and the many features of this wonderful software. Before we do that though, let's talk a bit about what Opusmodus is. So at its core, Opusmodus is a scripting language for musical events. It's a way to develop, transform, extend and organize any musical idea into a full composition. This musical idea can really be anything: an image, a graph, a poem, a data set about the movement of Pluto, which is not a planet by the way, or just a regular old series of notes with durations. We can then manipulate this data with countless functions and combine different ideas together in interesting ways. And one of the core principles which makes this type of processing possible is called parametric composition, which is a term to describe the fact that we process the different parameters of music separately before combining them again. Whenever you are working in a MIDI editor, for example, and you draw in a note, you have to specify the duration, the pitch, the velocity, and expression all in one event. With Opus Modus, we have the ability to separate these events and process them all individually before combining them again. As you'll see, this is a very powerful method for creating new ideas and expanding existing ideas. In order to do this, we use OMN, which stands for Opus Modus Notation. It's a very simple but highly effective syntax to describe musical events. We'll take a look at that in a second, but let's first explore the interface a little bit. When you start Opus Modus, you'll see that it's divided into two parts. On the right, we see the assistant window and everything related to the system, while on the left, we see the user area with the composer panel and user files. Let's start there. At the top here, we have 6 different buttons or tabs with a search field visible on each one of them. The search field here will search for functions and expressions in the user area as well as the composer panel, which is the main panel where you write your score. This search is different from the one on the right, where we look for functions, documentation, and other things related to the system itself. So if I type something here, I can see all the expressions and definitions with that name and the file it belongs to. The first tab in the user panel is for managing your files. It reflects the directories and files you have in your Finder. So these can be all sorts of files: text, PDF, audio, you name it. When we right-click on any of these documents here, you have the option to load them, which means all the functions and expressions in the file will be evaluated. You also have the option to either open them in the existing assistant window on the right or in a new assistant window. If you want to make some edits to a file but keep the previous version, you can create a duplicate, and of course you can also remove and rename files. All of these things can be done from within the Finder as well, since this area, as I said, mirrors the Finder. If we switch to the second tab, we find a directory where we can save our scores. It works basically the same, so we can think of all of these first 5 tabs as ways to organize our composing materials. These could be documents on the third tab, media on the fourth tab, where we can also store our audio, graphs, images, MIDI, video, etc. And finally, library functions on the fifth tab. Here you can actually add your own functions to the Opusmodus system, since the files here, when stored in the extension folder, will be compiled on startup. In my setup, you can see, for example, that I'm loading SuperCollider as well as the CLM instruments when Opusmodus starts. The last tab on the left here shows all the expressions you've defined in the currently visible document. If I go to My Scores, for example, and I open a score, and then I visit this tab, you can see all the functions and variables for this specific score. Now there is one difference between the first tab here and the other tabs, which is that this files area is changing depending on the workspace that you are in, while the other files are global. So if I go to File and then Open, I can navigate to the workspace directory. In there I can see a quick start directory and my own workspace labeled 2023. If I open the Quick Start workspace, you can see that all the tabs show the same documents and files except for the first one, which reflects the workspace directory in the Finder itself. This way you can separate your projects as workspaces while always having access to the same files. To create a new workspace, you just go to File, New Workspace, and voila. Now below our score we see the listener. Here we see the output for any expressions we evaluate, and if you're familiar with Lisp-based coding languages, you'll recognize this as your REPL. There are multiple ways to evaluate expressions, in other words, lines of code. You can do this by putting your cursor at the end of a code block and pressing Command E, or by right-clicking and choosing Evaluate Expression. You can also do this via the Tools menu. In there, you can see the various ways to evaluate. We can evaluate a whole score at once or individual expressions, which is basically everything between parentheses. You can then see the output of the evaluation in the listener window. You won't hear or see your score though. To do that, you can use the Evaluate Score menu or the associated key commands. We have the option to see the notation. We can play back the score in the built-in MIDI player. We can just audition it and don't show anything. Or we can evaluate it to the live coding panel, which automatically opens up a panel which allows you to set the position in the score and to loop certain areas. This feature is incredibly powerful when it comes to experimenting with your score or performing it on the fly, as they say. To stop playback, you can always hit Command Escape, which stops all MIDI notes and sounds. All of these visualizations and audition methods are also available for snippets, which are basically shorter pieces of code, such as a melody or a rhythm. With snippets, we also have the option to visualize them as integers, intervals, or even graphs. Since snippets don't necessarily contain information about the tempo, velocities, or even a note duration, we can set some global playback parameters in the preferences under Audition. If you set the port here to internal, you will hear the built-in general MIDI sounds, but if you want to, you can also set this to any of the MIDI ports on your computer to listen to snippets via your DAW, for example. To read more about snippets, you can find the corresponding document by using the search bar on the right side of the screen. Before we get into some more practical examples, let's actually take a quick look at this area as well. So let's talk about functions first and everything on the right side of the screen, which belongs to the system. As I mentioned, the window on the right here is called the Assistant window, and in it you can load any file you can think of. The first tab here is for the built-in functions, and this is really the heart of Opusmodus. These are the functions you use to manipulate your score in any way you can imagine. You can retrograde a melody, you can randomize parameters, do conversions, analysis, filters. It's really too much to even summarize. So this is where you will spend a lot of time when working with Opusmodus, and I'll show you some examples of the power of functions in just a little bit. First, let's take a quick look at the Documents tab. Here you'll find the documentation on Opusmodus itself and various other interesting composing techniques. You will also find examples for certain compositional approaches and 30 tutorials to get you started. I highly recommend you to work through these tutorials as they showcase a lot of different functions and teach you how to start thinking as a real parametric composer. Each of these tutorials comes with the score file and a PDF to explain what happens in the score, so it's highly informative. And a great thing, by the way, about these PDF files here is that they are interactive, meaning that we can audition snippets right from the PDF itself. If I open the Introduction to OMN file here, for example, and I scroll down a little bit, I can highlight these expressions and listen to them by either pressing Command 1 to see the notation or choosing any of the actions from the Tools snippet menu. This document, by the way, is another great one to read through as it explains the OMN syntax in detail, which is the language that we use to express musical ideas. And this syntax consists of the earlier mentioned 4 elements: length, pitch, velocity, and articulation. Here we can see a very simple example where we have a C4 with the length of a quarter note, a velocity of mezzo piano, and a tremolo articulation. All of these elements can be disassembled or assembled to work on them individually before combining all elements into a complete musical idea again. Now, to complete our interface tour, there are just 2 tabs left here, and the first one is for the system library. And what we can find here is things that we can easily import to use in our own scores, and we'll see an example of this in just a little bit. But for example, we have here some 12-tone rows, and we can now access these by just using the variable right here. At the bottom, you'll find examples on how you actually use this. So you have different categories, and you can sort of drill down to a specific thing you want to import, or you can collect multiple things you want to import. That can be very handy, and We also have our VST mappings here. So these are things such as key changes and articulations and stuff like that. So if we go to the viola, for example, well, you can see that if you want to use, I don't know, which one should we go for? If you want to use the spiccato, for example, you would send the key C2 with CC1 at a value of 127. Now, of course, these values, they depend on the specific VST that you want to use. So if you have something that's not in this list, you might want to refer to the manual. You can see a lot of examples here, and you can see that there's a lot of already implemented, like Piano Tech and Kawai and Cork and Waldorf, etc. So this is what you can use to more easily switch to a certain articulation in the score. And after you've set this up, you can just refer to it by this variable right here in your def score, which we'll also take a look at. So that's for the library itself. And then we have a search function. And this search here is different from the one on the left. Well, first of all, because it searches the system rather than the user files, but it's also much more much more intuitive, especially if you're starting out. So let's say you just opened Opusmodus for the first time. You want to do something with pitch, and you search here in the regular search for pitch. You can see that there's a lot of functions that do something with pitch. So that's why this more advanced search is here. What you can do here is you can say, all right, I want to, let's say I have integers, numbers. So I can start typing here. As soon as it finds something, I can, with the arrow keys, select the specific thing I want to use as the input to the function. And now we filter down all the functions that take integers as input. Then I can say, all right, for my output, I might want pitch. And you can see that if you have enough characters and there's only one unique completion, it will automatically complete it for you. And now I see the two functions that take an integer as input and they output a pitch. So this can be very handy and save you a lot of time when searching for something specific. And then the other thing we can search for is intent here. So we can say, for example, that we intend to combine something. So we can type combine and we can see the function that does that, only one, which is great. Then you don't have to choose between the outputs. For the operation, or for the category rather, we can choose a category of things. For example, we can search for predicates, which are functions that return either yes or no, either true or false, or if you think Lisp, either nil or t. This will show you all the predicate functions. Usually they end with a P. And we can search for operations as well, such as we want to generate something. We can see everything that generates something. Now, if you want to get an overview of which search terms you can, or which basically parameters you can set here, you can go to your documents again, and you can find function search. I already saw it there. No, I don't see it anymore there. And here you can see all the inputs that it can take for the various search fields. So you can see that intent has a lot of different ones, category as well. So that's that's something to refer to if you want to search for specific things. All right, so that is most of the interface out of the way. There are some things left, but I want to show these in the context of working with the composition. So next, what we're going to do is we're going to take a look at a couple of different compositions, and we're going to go over them. And while we're doing that, I will show you some other things that we can do with Opusmodus. So now that we have the interface out of the way and the UI, and we know a little bit how Opusmodus is laid out, let's take a look at some scores so that we can see how we can actually work with it. So the first one I want to take a look at is this one right here, which is called Serenata, and it's based on a work by Bruno Maderna, which is an Italian very famous composer, and he made a similarly famous piece, which we have somewhere here. There it is. And this piece, it basically, he created a bunch of patterns, and the musicians that played the score, they were free to choose any of these patterns at will. And that's what's happening in this score as well. These we randomly choose various patterns from this, and then we apply some rules to them. So the first step in this score, well, actually the first step is setting a seed value, which is to fix the random output to always evaluate to the same results. But then after that, we are importing this from the library. So let's actually see if we can find it here. Libraries, Moderna. And here we can see the original patterns. So these are all being imported, and we collect all of them. And then we are creating 3 different dictum variables. And the dictum, this is used in various places in Opusmodus. And what this does is it's a way to, let's say you're working with some random content, and if you have a dictum, there's a way to force a certain thing to be a note or a tempo to be a certain position, so that you have control over the output still, even though you might start with a sort of random process. So what happens here is that in the first line here, for example, we can see that this first list, and this is for the 4 voices that we have. And if it's a hyphen like this, it means that that voice will rest here as well. And then here for the position of the 3rd voice, we see a 1, which means that this will start playing in bar 1. It will have a span of 3/4. That will be the length basically of the melody. If it was 4/4 before, now it will be cropped to 3/4. The last beat will be cut, and we set the tempo as well. And then here you see these methods, and these methods are the dictum items. So we can once again look for dictum here in the sidebar, and we find this unfold set. And these are basically shorthand variables to longer rules, such as length divide, pitch rotate. We have some gen retrograde. RL means retrograde. It will retrograde the length, or it can retrograde just the velocity. So there's a lot of things that we can do, and we can apply them to specific voices. This is a very handy mechanism. And it's something you want to take a look at. I mean, I know right now it might look complicated, but it's really quite simple once you get the hang of it. Now, all of this is then being fed to the counterpoint function. You can see that dictum A is being provided as an argument. Whenever you want to see which arguments a function takes, you can put your cursor somewhere near or in the function name, and then you can press Control Y, which will show you the arguments that it takes. So everything before this ampersand key are the required arguments. So you need to specify these. In this case, they are patterns and dictums. So Moderna is the patterns that are imported right here, and the dictums are being created right here. Now, if that's not enough, you can press Escape to go out of that, and you can then do Option Command F, which will search for this function in the search bar right here. And then you can actually see the full documentation for, in this case, the counterpoint function. And you can see how it works. You can see some examples. And once again, remember that we can evaluate all of this as well. We can see it in the listener. We can also listen to it. We can see it as a score. I mean, we already see the output below here, but it's that's really nice about these PDF documents, that we can listen to things straight away. So we have that, and then finally we first assemble all our voices. This is just a way to merge those lists together and make it into one piece, and then we send that through a PS function, which stands for preview score. And this is an easy, quick function to listen to your score. And there's a more complicated way, which is called dev score, and with this we also have the option to specify MIDI channels and a whole bunch of stuff. But with preview score, it's meant to quickly hear our results, and that means that in this case the MIDI that will be used will be playing general MIDI sounds that are built into your computer already. So no fancy libraries, nothing like that. But still, you'll hear that it sounds very good still. So if we do Option Command 1, we get the audition and we get the score as well. So let's hear what this sounds like. going to stop it right there because this is a very long piece. But you can hear that the general MIDI actually sounds pretty good. We can also see that patterns here is being printed next to the pattern, which is very convenient. We can see the tempo. We can hear the tempo changes in here. So hopefully this shows you that you can make very complex, elaborate scores that actually look great as well in Opusmodus. So let's take a look at another example. So the score we see here is simply called Choralis, and that's a very apt name because it uses the Choralis function. And what this function does is you can give it a chord progression with either 3 or 4 notes per chord. And what it then will do is it will apply all the rules of SATB writing, like a choral writing, and perform very smooth voice leading. So you can just give it a very very unstructured chord progression just with the chords, and it will handle all of the other things for you. And when you work with this, you have a couple of parameters that you can say. You can specify the rotation, the path, whether it will go to the relative closest path or comparative, or just randomly choose. You can choose a maximum intervals, etc. And then you have these methods here as well. And these are very similar to that dictum we saw before, unfold methods. And this we specify here. So, for example, we say that the soprano voice in bar 6 will be transposed 5 semitones, or we will say that the bass will be transposed down an octave in bars 1, 2, and 3. And then finally, we run that through a preview score again. So let's listen to this. So you can hear there that we that all the rules of proper traditional voice leading are being applied, and we, in a very simple way, we end up with a beautiful score, and we have some control over the output as well. So yeah, definitely wanted to show you this one. The next score I want to take a look at is called DADA Quartet, and I mainly want to show this because it beautifully exemplifies randomness, or in the case of jazz or any genre, we could also relabel this as improvisation. So what we see at the top here is an init seed, and this is a arbitrary value that you set to fix all the functions in this file that have a random output, or it can have a random output, to a specific value. So if you keep this number the same, it will always sound the same, but you can change it to get different variations on the piece, which is a very nice way to quickly listen to some variations, basically. Then below that, we can see this is actually what we just looked at. We have our program attributes, which creates a sound set. So basically here we create a variable and we assign that to a key switch. So if we work with the Vienna Symphonic Library and the tenor sax instrument in there, we can now control which articulation of that instrument we want to use. And then below that, we can see our library functions. Again, we import some tritones from the Slonimsky library. And then below that, we see some repeat functions. With all of these, remember, you can press Command E to evaluate. You see that this one repeats 8 times the number 1 and puts that in a list. And then below that, we can see some beautiful example of parametric composition where we work on individual elements. So here we create a list of lengths, and then we randomly choose 200 values from that list, which will give us this output. And then we create some time signatures. So we basically go through that until we eventually make our theme itself. Now I'm going to scroll down a little bit because there's a lot of different functions in here. Here the assemble seek, for example, this is a function that's very handy to merge your themes together into one piece. And we create some different instruments right here. We have some bass, we have some drums in here as well. Some of these functions we'll take a look at later. And then below here we have actually two def scores. So you can see, so the def score is an important function because this is what you eventually use to either send everything to a MIDI port. That's the example that we see here, where this is basically the melodic and the rhythms, and this is your theme. Then you say which channel you want to send it to, which program there you want to use. Here you can see another example. Let's remove this one for now. Let's just focus on this one. So first thing here, you can set your title, you can set your name. This one is created by Janus. Then you can set a copyright. All of that is optional. A key signature as well. This is chromatic because we are sort of we do a lot of chromatic stuff in this piece. And then you set the layout, and the layout is how the score will look. So you have, for example, a grand piano layout. You have layout for drums. You'll see more examples of that. And then for each of the instruments, you say which theme, which melodic material it's going to use, and you can send it to a channel, etc. And then here you can see a more compact format of that. All the drums are on channel 10. So after you've assigned that once, the other drum instruments will automatically take that value. So let's listen to this and hear what that sounds like. So what you can hear is that you can get a very expressive piece, which really sounds improvised by real musicians. A very powerful way of creating multiple variations of an idea. Here, we're really talking about the concept and then turning that into an almost infinite amount of compositions using different seed values for the randomness. All right, let's take a look at another piece. The score we're looking at here is called Micropolyphony, which is a technique that has been developed by Ligeti, a Austrian-Hungarian composer, and it involves using chords with very small intervals in between the chord tones, mostly major and minor seconds. And the result of this is a very dense, full, complex sounding music, very beautiful. This is something we can hear, for example, in The Shining or in the movie 2001 Space Odyssey. I believe it's Kubrick that made Ligeti famous with these movies. He really loved the sound, and there it sounds very, very eerie, very scary. Definitely check those out. But we have access to that technique in Opusmodus using the micropolyphony function. Now, if you want to look up how that works, I might have told you before that we can use Option Command F to look for functions in the search bar. This key command has since been changed, however, and it's now simply Command D. So if you put your cursor somewhere in the function and you type Command D, it will find it here, and we can look up what it does. So here what we can see is this micropolyphony function takes at least 4 arguments, or 4 required arguments: the voices, the events, and the minimum and the maximum lengths. And then we have a bunch of optional arguments as well. So those are being defined here. We can actually take a look at this ourselves as well. Let's type micro, and then what we'll do, if we want to be fancy, is we type tab, and we can see all the completions for what I've typed so far. If I, for example, only type an M, we can have everything that starts with that. If I type micro, like now, there's only one completion, and you can press tab again to complete it. Now, let's say I also want 4 voices. I want 10 events. Let's do 116 to 14. And let's take a look at that. right? So you can hear those very close, the kind of dense sound. Now you can see that this has created 4 separate lines. We can get access to those individual lines if we use this argument, the keyword argument index, and let's just call it test, for example. Let's evaluate that. And then what I can do is I can simply type test 1 to see the first of those. And of course, I can also do that for 2, 3, and 4. So that is basically, I will remove this. By the way, I use Control K to remove a line. We have all the Emacs key bindings available to us in Opusmodus. So if you're used to those, you'll be very happy with that. So what's happening here is we do that and we create a Micropolyphony, 4 voices for the left hand and for the right hand. And then here we merge 2 of these voices together. And if we take a look at that, you can see that since we're working with 2 voices that are very close together, in some places this can look a little bit messy, like there. So in order to solve that, we then go through a dissolve voices function. And that makes sure that it blends the voices that are actually playing the same note, and wherever they're playing a different note, you will see that, of course, as well. So we have that, and then we create a time signature from the lengths that we created, and then we apply a dictum to specify some additional rules on top of what we've created with the Micropolyphony functions. And then finally, everything is going through a depth score. So let's do a option command 1 to listen to everything through our depth score. No, I really like that score. You might, by the way, notice that if I evaluate these snippets, I get a different sound than when I evaluate the whole score. That's because here in my depth score, I'm setting a port. This port is a port from the IAC driver on Mac. If you go to Audio MIDI Setup on Mac, you can see your IAC driver here, and you can create new ports there. Now, you don't have to do this, although you do have to make sure it's enabled. You could you don't have to name them. I mean, you could also say port 2, for example, or port 1, and that will also work. I just name them for my own sanity. So that's why this goes to that MIDI port, and that goes then to Reaper, where I have a VST piano loaded. So that's the sound that we hear. Whereas my snippets, if I go to the settings right here, and we go to audition, then we can see that the port here is set to internal. I could set it to the same, but I like my snippets to go through, just use a generic sound, because that way I don't have to open any DAW or do anything to listen to something, right? So that's that. If I want to hear that sound in the depth score, I can say, do something like this, say sound is general MIDI, and I can give it a program number. Now, because I like this score, I might want to print it. And the print command, as we all know, is Command P. So if I make the notation viewer active and I hit Command P, we get this window where I can say open in preview. And then we get this little overview right here where we can change a couple of parameters still. I can change this snippet number there. I can outline the composer to the right. I can say here, for example, copyright. What else can we do? We can scale it as well. Let's see if we can get everything on one page. Okay, we can, but it's a little bit small. I will go with 2 pages, and then I simply hit print, and then it will actually open it in preview. And now I can either print it or I can just share it digitally. It's now a PDF file. There are multiple ways to create a score, but this is a very to create a printed version of a score. But this is a very fast method. All right, so that's Micropolyphony. Definitely play around with it. It's a lot of fun. Let's take a little bit of a detour and talk about CLM, which stands for Common Lisp Music, which is developed by William Schotstedt, as you can see here. I don't know if I pronounced that well. And this is basically a Lisp library that allows us to do some sound design as well. And this has been fully integrated into Opusmodus. And what that means is that we have these functions that we can use, these different synthesizers, and we can use all the other Opusmodus functions in combination with that to do sound design. So sound design and composition, I should say. So let's evaluate this, and let's just listen to that first. So as you can hear, that sounds absolutely beautiful and very complex full sounds as well. Now, what you can see here is that we actually see an output folder here. If I evaluate something and I don't specify a file name, if we go to our library here, no, our media here, and we go to audio, then you can see that this has been called test.aif. That's this file. Every latest thing that you evaluate in CLM will be written to this file, so it will also override it. You can just play it right from here. So this is definitely something cool to look into. One thing to point out is that if you want to use this in your extensions, you want to go to load CLM instruments. You want to uncomment this line. You might also need to install the command line tools, but then you can use all these different synthesizers, and they all work with Opusmodus straight out of the box, as they say. By the way, we can click here to go to different completions. We can see here previous files that we've opened. And so the last one here was partials. Let's go back to that. You can also, there's documentation for all of this. So if we do Command D, we can find this here, and we can see all the arguments again, and we can specify, and we can see a lot of examples as well. So these are really fully implemented. If you want to go even further than that, you can find, let's see, let's type CLM here. You can find the more examples. Let's open that in the composer panel. And here you can really start messing around with the full package itself. And this would be much more pure Lisp, and you can do some really cool sound design with this. So for the adventurous, also check that out. But if you're if that looks a little bit too daunting, rest assured that you can use all of these predefined synthesizers in Opusmodus, and they're really flexible. You can do some cool stuff with that. So yeah, don't miss out on that one, I would say. The score we see here is called Polygon, and that's for a good reason, since it uses the Polygon rhythm function, which we can see on the right here. Or actually we see the circle rhythm plot, but this visualizes what a polygon looks like. Basically, it's a surface with a variable amount of edges, and we can use that to create rhythms. And remember, we can evaluate all these things here, and we can then see the graph right from the PDF. We can of course also copy it, and well, just for that didn't copy it correctly, let's copy it just for the sake of experimentation. What you can see is you can define the number of points. So I can say, for example, 24, and you will see that I have 24 total points. Then I can define the points where I want to see a dot, and it's going to draw a line in between these dots. Now, the other function, the polygon rhythm itself, let's do a Command Option F on that to search it. It works slightly different. Here we set a starting value as well, and the number of points, and again the number of edges, and you can see again that these are similar examples, and typically we use this to create rhythm. And this score makes clever usage of that, because what it does, it creates a list of pitches, which we can see right here. And then it loops over every pitch in that list, and it will create a rhythm for each of those pitches. So it will create a unique rhythm for each of those pitches, and that is like at the heart of the score. Then I also wanted to show this because this score is very well laid out. It's very well organized, and it all uses single functions, or mostly at least. What I mean with that is that, and this is a thing that's common to Lisp, is here, for example, you see an example of a nested function, which is a function that takes another function as its, so the output of this function is an argument for this function right here. And if we have lots of nested functions for beginners, it's often a little bit more complex. So this score is a nice one to look at because it's uses mostly single functions. But here, just to explain what happens here, we have a chord interval replace function. The name is pretty self-explanatory. What this does is we specify the intervals that we're looking for, and then we specify what we want to replace them with, and then we need to give it a sequence. So the sequence, this MB line, that's just a list of pitches once again, and then we say that, all right, if the interval is either 1 or 2, we want to replace it with 5 or 7, and then the output of that, which looks like this, then goes into the chord pitch unique. And this function will make sure that there are no double notes. So if there's ever a pitch that's repeated, we can see that right here. This is a nice example. You can see here there are two Ds here, two D notes, and you can see that in the output of that, that second D, or the first one, who cares, has been replaced. So this is a little bit about this score. Then we can see that we have 7 instruments. For all of them, we apply a dictum, we transpose the pitches, and we use the ambitus here. And this is a nice function as well, because this is sort of a filter that makes sure that things are in a certain range. And when something is outside of that range, we can decide what to do with it. So it says by default, the value falling outside the range is transposed up or down an octave. But we can set the type here. We can also invert it or do a flat inversion. So ambitus is great. You give it a range and then you give it an instrument, and it will make sure that it stays within that range, which of course for orchestral music, where you work with real instruments, like these instruments, they have a physical range that you, if you want it to sound realistic, you want to stay within that range. So that's what we do here. And then again, we have our def score, where we combine everything together. Here you can see a more fully featured score layout. We can see that we create 2 bracket groups, and in those groups, we create the different instruments. So let's listen to this. So you can hear that this piece is rhythmically very interesting, or harmonically as well. But the main power of that is this polygon rhythm function, right? So this is a nice one to take a look at as well. One way in which I like to use Opusmodus personally is to extend on an idea that I have. So you might be in the situation where you have a melody or half of a piece or 16 bars or whatever, and you want to create some variations on that. So what you can do in Opusmodus is you can take this melody, this composition, here's an example of that, and you can just put that in as regular Opusmodus notation. This is just regular score notation. We can take a look at this. Right, so that's our score, and then what we can do is we can start to process this in in a lot of different ways. But what we're doing in this score specifically is first we set a length augmentation. This basically multiplies all the lengths of the right hand. This variable, this basically this piece, it multiplies everything by 4. So if we listen to that, right? It's just 4 times as slow. And then we fetch the time signature from that, and then we split it into two parts, Met1 and Met2. And the only difference is that they're going to be now 2 octaves apart. So one is transposed up an octave, the other one down. And then we create two voice variants. And voice variant is a function that takes a sequence, which is what we have right here. And then it applies various operations on that based on the rest, the tuplets, and it basically creates variations on your theme. And then once that is done, you can see here that you also have options to retrograde and to you can do quite some fancy things in that to end up with the variation. We can see the variation in the listener right here. And once we've done that, we set a length weight. And this function I also really like because it takes, once again, a sequence. Remember, we now have two because we split it. And then we can set the weight of the length versus the rest. If we take a look at this function as well, we can see that the first value is the weight of the note length. The second value is the weight of the rest length. So in other words, the higher you make this first value, the more likely you're going to get notes. The higher you make this other value, the more likely you're going to get rests. So we can actually let's take this function right here and let's take a very quick look at that. So we have our len right here, a list of lengths, and then we have a length weight, and we can specify the weight parameter. We give it a list of two values. Let's say the first value is 4 and the second is 1. And then we evaluate that. So you can see that right now we end up with mostly notes, right? And if I make this value higher, let's say 40, most likely we're going to end up with only lengths. Now, if I make this other value higher, let's say 100, we're going to end up with mostly rests. We only have one note in there. So this is how to set the difference between lengths and or like notes and rests in your piece. And then finally, we take that all into a def score, and we send it to channel 2 and channel 1 using the general MIDI sounds. So let's listen to that. And we can compare that with the original piece as well, the original thing that we started with. Let's analyze this in the MIDI editor. Right, so you can hear that it has made some very nice variation on it. The core of the piece is still there, but we now get a different version of it. One thing in Opusmodus that I'm personally very excited about is the integration with SuperCollider. And SuperCollider, in case you don't know it yet, it's a environment and a syntax for sound design and composition. And with it, it basically consists of a server and what they call the language side. And on the language side, you write your synthesizers, you write your melodies, etc. And then you send this to the server where the synth is living, if you created one. And this can then processes the audio or creates the audio for you. It's made in the 90s somewhere. It's a very mature product, has a wide user base. So if you're into sound design, it's definitely something to look into. But we have this in Opusmodus as well. Now, of course, I cannot explain all the things going on here. It's quite a vast topic, but I can show you some sounds and the basic structure. So, for example, one thing you need to do to get started with this is make sure that you have your that you load SuperCollider on startup. Remember, at the beginning we mentioned that what you have here in the library under extensions, you can find this file, load CL Collider, and if you uncomment these lines and you set the path to where this where the synthesizer lives, so this one is always the same, this one you have to customize for your computer, then you are able to use this, which is great. And I'll just give you some examples here. Like after you start the server, So you create a server on a port, and this can actually be, right now it's a local server, but you could actually control a server on a completely different computer and do some, I don't know, work together with someone else. Well, here's an example of one sound. It's just kind of the standard Super Collider sound. And then here, this file is a little bit messy because I'm just experimenting with things. But here's, for example, a synth definition. We define a synth here, which we call PM Crotel, whatever. And we set some parameters for that, which we can later then control. So one of the parameters, for example, is MIDI. We can see that in the input arguments. So if we create this synth, it will now push it to the server. You just see this at the bottom right here. And then we can trigger that synth with certain nodes by just evaluating this line right here. And this one, it chooses a different random number for both the pitch and for the tone. So every time I evaluate it, it will sound different. I can make this a little bit higher as well. And of course, you can put this in loops as well to actually create your composition. So one thing I'm actually currently working on is, let's see where we can find it. It's right here, Super Collider project. And what I did here is I separated the synth files. So these are both synth definitions. I separated that from the score aspect. So if I evaluate these synth first, the server will know about them. And then I can go to my score. And here I have some regular Opusmodus notation, a regular melody, which I can show you as well, just so that you can see what the melody looks like. And then I'm using that inside a loop here to control an actual Super Collider synth. So if I evaluate this and then this, and there's actually, this is just one example, but there's a lot of stuff you can do with this. You can also work with audio files, for example. Let's see if I have some examples here. Here we have a cello. Let's see if we can listen to that. We have to choose this one. So you can work with audio like that. I have here some sort of Foley sample. I can try that as well. Right, so that's just something I wanted to point out. I should also mention while we're on the topic that Super Collider, it works with OSC messages. Maybe you've heard about them. It stands for Open Sound Control. And these messages, it's sort of, I mean, you can think of it as MIDI, except that it works over a network and it works much faster. Super Collider, as well as a lot of other things such as Reactor and Reaper and a lot of software accepts OSC messages. This is also something we can do with Opusmodus. So we could also send OSC to Super Collider and then use the application itself and just send messages in an OSC kind of pattern. I have a couple of videos about that on YouTube in case you're interested. And of course, you can also send MIDI from Opusmodus, which is something we'll look into towards the end of this video. The last score I want to show you here is one of my own, and mainly I want to show this because I'm using some modulation and sending everything to my DAW, which is something that we haven't really looked into yet. So to start at the beginning, we start with a list of chords, and this is the whole basis of the piece. From those chords, we're creating the melody and the chord progressions. And in order to do that, we use these harmonic pad functions, and we have another harmonic pad function here. So what this takes is a source, which is a melody, and then it takes the chords itself, and then it maps the melody onto the chords. Let's see if we can listen to that by itself. So first we have the chords without any tempo or rhythm information, length I should say. And if we don't specify a length, the length that's used when we audition a snippet is the length that we set here under the audition. So if I set this to half notes, for example, it will play back a little bit slower. Right, so we have that, then we generate a rhythm, which you can see right here. We could also listen to that, pressing Command 1. That's the rhythm. And then we repeat this melody that we set here based on the size that we set at the top. We create some velocity information, and this will just repeat the same melody. But then we map that melody onto our chord progression so that the notes will be one of the chord tones. Right, so that's how we sort of progress. We do some filtering and we create some variations on the theme. Here we use a filtered tie. Filtered tie makes sure that if we have two repeated notes, it will tie them together and make one longer note. We use the same function here. So we do all of that. We create a bunch of sections. Then here I have everything related to the drums. This uses the Polygon rhythm, which I've showed before. We can actually take a look at what that looks like. I've commented this, but we can plot our head, our snare, and our kick in a circle rhythm plot. And if we evaluate that, we can see where everything hits. So you can see, for example, that the hi-hat, it has 16 points, and it also has 16 values. So it basically plays on every 16th note. If you do something like 12 here, and then we evaluate this again, then it will only play at 12 of those 16 positions, right? And then we see which one is the kick. I think the green line is, or might be your kick. And then we have the snare showing in yellow, I believe, because the snare has the least amount of points. So we have that, but what I want to show you here really is is all these vectors right here. I'm not using all of them, but these vectors we can use for modulation. We can also use them to create melodies. For example, you can generate a sine which will look like this, but if we plot that, we can say vector 1, and we can look at it, we can see that that is indeed a sine wave. We can of course use this and map this to a melody, and I have some videos on YouTube showing that. If you want to take a look at that, look at the 100-second video series on Opusmodus that shows how you create a whole score with vectors. But here we basically create a bunch of modulation shapes. Some of them get more complex by using nested functions as we go along. One example of that here is this vector 18. If we look at that, if we first evaluate that and then we throw that into a list plot, we can see that this is a exponential curve which has a total of 256 values. And the reason for that is later in the score we're using this vector 18 here, and if you take 256 of those values and you divide it by 32, we get a value of 8. What that means is that, like, this is the total number of bars that we get. So we get 256 values divided by 32 is 8, and because we use a rate here of 132, that will end up being 8 bars. So this is how you calculate the modulation length. There's another video on YouTube as well showing this. I believe it's the one about Polygon rhythms, or possibly the one about automation. So we do that, we create a bunch of curves, and then we can use those in our gen controller function right here. You see here 2 ways to generate controller values. So the first value here is the CC number. So here we have a CC of 78. If you do 1 here, for example, it would be the value for your mod wheel. And then this here is how to sort of manually specify values. What I say here, hey, I want the value to be I want the value to be 0 for 16 bars. And then I say I want the value to be 127 for 32 bars. That's one way to send fixed values. And you can actually, you could also say for 1/16 note, for example, if you do something like this, it will generate a value of 0 for 1/16 note. But I'm here just initializing it to 0 for 16 bars. Then after that, it will jump to a value of 127 at 32, at 32 bar for 32 bars. And then for CC number 79, we use a different technique where we use these gen controllers, and we combine that using a assemble seek. But this gen controller function, let's see if we can take a look at that. Gen controller generates controller values in a given span, total length. And it says here the count of the sent messages is the sum of the time values equal to the span value. Now, that's that thing that I just mentioned. So here, if you have a span of 1/4 with a time of 1/28, it will produce 32 values. This is why here I'm using that 256 total values, because we need to divide that by 32. All right, enough talking. I will play this piece, and then I will switch to Reaper, where we should see all these values being modulated. Let's go there. Let's do a option command 1 to evaluate the whole score. Right, so there you can hear more of an electronic piece with some side shading and some typical synth sounds. What I'm using is to change the melody. I'm mostly using one instrument, but I'm just using these macros in Serum to, for example, increase the attack on a Neil section, or actually lower the attack on a Neil section, make it faster. You could see some filter modulation using generic sine wave. That's this vector right here. So this is just to inspire you to start working with vectors. I mean, they're really cool. They can create all sorts of shapes. And for me personally, one of the reasons why I wanted to do more with Opusmodus, here's a beautiful saw wave, for example, is exactly this. I got very tired of drawing automation inside the DAW. It's one of my least favorite tasks to do, and with just this, I just found it much more convenient. It's super accurate. So yeah, that's what I want to show you. One other thing I want to show you is, well, here at the bottom we have a command to, or a function which displays the MIDI if we compile this score. And there's a couple of handy functions like this. You can also, for example, save the MIDI file right away. But one that I haven't showed you yet, which I think might be handy for some of you, is the one called Music XML to editor. And that's a function which takes a file name which we can specify ourselves. So we can say test, for example, and then we can specify an application where we want to open that file in. So I can say, for example, MuseScore, it's MuseScore3.app, and end with the quotes. So now if I evaluate the score again, it starts playing, but you can see that it also opens MuseScore, which apparently I need to update. Would you like to apply who the hell is Edwin? No, then do not apply Edwin. And then we can see our whole score in there. And this, of course, also works for, I mean, you can make it much neater than this, but this works for your DAW as well. So you could open your whole score in Logic right away. And this is another thing that I really love, because what that allows me to do is really focus on the composition side first and work just with, mostly work with MIDI and really focus on the notation and the score itself. Then when I'm ready to do a mix down, I will very quickly and easily open it in my favorite DAW, which tends to change from time to time. And then I can finish it there and use all my VSTs and do some more mixing kind of stuff. All right, so thank you all for watching this video. I hope it gives a good overview of what Opusmodus can do. If you still have questions, you can always ask them on the Opusmodus forum, or you can put them in the comments here below the video. But I hope by now you're just as excited as I am in using this software and exploring more about it. It really has been an amazing journey for me so far. All right, thanks everyone.